Hello all, my name is Nathan Zimmerman. I'm a junior in electrical engineering at NDSU. This is an electronics project that I was required to make for class. It is by no means my senior design project, and also again I'm a junior, so go a little easy on me. Anyhow, this is what I decided to create. It is a laser-based security system. I got a LCD screen right here to tell us the status of our security system. And then I got two LEDs right there, also to show us our status, and two push buttons right there to enter a code into the LCD screen in the event that our security system is breached. Now what I have going on here is I have a 5 milliwatt red legal laser, and I am shining that at a receiving LED. Now I'm sure you all know how if you turn a motor, you generate a voltage. Well, the same thing happens to work with a LED. If I shine a red wavelength at this LED with my laser, I'm actually generating a voltage on the LED, and that is being received by my microcontroller and is interpreted as the security system isn't breached. So now here's a demonstration of how it works. If I breach the system, as you can see right there, security system is breached, and then we have this little LED to blink us to inform us that we need to enter the password. As you can see there, it says please enter password. Now we got these buttons here, and I'm going to enter the password on the buttons. Now I'm going to wait a little bit here, and as you can see, that red LED light came on, and that is to signify that we did not enter the password in time and that the alarm is going off. Now what I got over here is a 120 decibel alarm. I could have that hooked up to the board. However, right now it's kind of late at night, and I'd probably get kicked out of the building if I were to fire that thing up at midnight. So I'm not going to do that, but as you can see, the red LED is blinking for proof of concept. I probably need to extend the time to enter the password, but you get the idea. And so now if I hit the enter button with my password here, that should hopefully reset the system since I entered the correct password in. And again, it says laser system now activated. And as you can see, it's working again. Now you're probably thinking there might be a few flaws with this design, such as say I wanted to bypass that little area on my desk, and so I grabbed another laser and shined it at the LED while I was going through the field. Well, one thing that I'm doing is I'm actually pulsing that laser. So I got another laser right here. I'm going to try to shine that at that laser, and as you can see, this laser turned off, and our security system is back to its breached status. Now I'm going to try to reset our system here, just with the power pin, because I don't want to have to re-enter that password again. Alright, there we are. And again, laser's system now activated, and there's an example of how it works. There's a scope probe that I got hooked up to the LED, and if we follow that back over here to our Rigel oscilloscope, as you can see, I'm actually sending it a PWM wave, and what it's doing is it's sampling both the high points and the low points in the wave. So if either isn't apparent within the given time interval, it'll trigger the alarm. So again, if we trigger it by shining a laser at it or trigger it by blocking it, either way, same result, the alarm goes off. We also have these buttons over here that are interrupt based, and again, I can enter my password or whatever, and no matter how many times I push this button or whether I hold it down, ultimately the alarm will sound in the same given time interval. What I did is I have a timer for that, and it's the highest priority, so no other interrupt can possibly preempt that alarm going off. So again, that's another feature, and regarding the project as a whole, the microcontroller that I'm using is the MSP430 Ti launch pad. This is a complete development environment for $4.30. You cannot possibly beat it. I don't know how TI can afford to do this, but they ship you USB cable and a development board and a couple TI-based microcontrollers that are DIP-based. And again, this was just very ideal for my project because it was so cheap. And ultimately, for hobbyist projects like this is really all you need. Now, I know there's a lot of people out there that are fans of the Arduino, but I mean, ultimately, in most cases, this is simply the most ideal, because you don't need a super advanced microcontroller to perform a simple hobbyist embedded application such as this. Now, say you were building a cell phone, some mobile controller, or engine controller, I could understand why you need an advanced AVR processor. But in most cases, the 30, 20 bucks, whatever you pay for AVR is just completely put to waste. So again, I highly recommend the MSP430 Launchpad, and again, just worked great for my application. It has 10 GPIOs, and on my system I'm using all 10 of them. So great value in my case. I'm sure it's not for everyone, but just to try to get the name out there, I would highly recommend this. You cannot possibly beat the price for performance that you get with the Launchpad. So again, Nathan Zimmerman. Here's my simple embedded application, and if you stay tuned, I'll show you a little bit about the board itself. Alright, so here's the board itself. What we got here is a 8-bit parallel LCD screen, and on the top of the board we also have our two debug LEDs, or status light LEDs, whatever you want to call them, and then we also have two tactile push buttons. Now, on the bottom of the board we have our MSP430 microcontroller right here, and then we also have a 8-bit shift register that I'm using to reduce the GPIO usage of the LCD screen. So with this setup, I only need about 3 LCDs, or 3 GPIOs to control this LCD screen, whereas if I didn't have this shift register, I would probably be using all 10 GPIOs on my microcontroller. I also have a LM393 comparator that I'm using to buffer my laser input. I also have a LM358 op amp that I'm using as a driver for my LEDs. Some other features: I got a 5-volt rail right here. See if I can get this in the light. 5-volt rail, 3.3 volt rail, and then I have two low side driver MOSFETs. I have one low side driver for my 120 decibel alarm, and then I also have another low side driver as a driver for my laser. Then a few other features I got: I have some headers, as you can see on there. That's just for various power modes. I can basically turn everything off except the laser and the microcontroller, and I can get down to about 500 microamps, and if the laser is tripped, it'll sound the alarm. That's just another feature that I built into this. The PCB itself is of exceptional build quality. I got it from Dorkbot PCB. They're a hobbyist group order PCB company. This board costed me about $10 per board, and I just shipped my Gerber files off to them, and about 2 weeks later I got this back. And again, exceptional quality. You got silk screen on both sides. You got some I think they're gold plated vias and gold plated pads. I don't know. Ultimately very satisfied with their process, and again, highly recommend their use. And so yeah, that's just the basic hardware behind this project, and hope you enjoyed it.